1.2, here are our objectives for today. Okay, solve linear equations in one variable, solve linear equations containing fractions, solve rational equations with variables in the denominators, recognize identities, conditional equations, and inconsistent equations, and solve applied problems using mathematical models. Now, I'm going to go ahead and talk about number 5 first. Okay, just because basically solving applied problems using mathematical models, how could we reword that? Solve like sentence problems, right? Word problems. That's what that kind of means right there. Okay, so all this stuff that we're talking about up here, this one, it's just word problems of those. Okay, you okay with that? All right, solve linear equations in one variable. So they could be as simple as this. Can you solve that equation? 2x plus 5 equals 9. What would you do first? Subtract 5 from both sides. It's to get rid of the 5. Okay. 2x equals 4. And then divide both sides by 2. So x equals 2. How could we be positive that that's the correct answer? So 2 times 2 is 4 plus 5. Does 9 equal 9? In every universe that I am aware. I have not been to them all. Okay. Any questions? Do I need to do a whole bunch more examples of that, or you guys got linear equations? Okay. So when it says linear equations containing fractions, what it means, let me show you that again. Number 2, our objective number 2, solve linear equations containing fractions. That's going to be basically like 2x plus 5 over 3 equals 9 over 6. I know that can simplify. You be quiet for a second. Okay? Same kind of thing, but we've got to get rid of the denominators. Wouldn't that make it a lot easier if there was no fractions? Well, what would be the common denominator here? It would be 6, right? 6 is the smallest number they both divide into. So what if I multiplied both sides by 6? There and there. Well, that would simplify, wouldn't it? 6 divided by 6 is 1. What would this simplify to? A 2 right there, right? So everything on this side of the equation will be multiplied by 2, so I get 4x plus 10 equals 9. And is that a linear equation you know how to solve? Subtracting 10 from both sides gives me 4x equals negative 1. Dividing both sides by 4, x equals negative 1/4. You okay with that? Okay. Do I need to do any more of those? Are you guys pretty comfortable with those? Comfortable? Okay. Our third point was solving rational equations with variables in the denominator. So that's something that, at least in Algebra 2, we worked on quite a bit because they're not necessarily hard, but they're definitely not the easiest things that we did in Algebra 2. Okay? So, trying to get an example problem for you real quick. Sorry. I had it turned to the page and then I closed the book on accident. Okay. So for example, just to start with, what if we have, let's see, 4 over x equals 5 over 2x and then plus 3. 4 over x equals 5 over 2x plus 3. Well, what would be the common denominator that we would have here? 2x, right? 2x is the smallest number that everything divides into. So if I multiply the entire equation, every term by 2x, we can see what happens, right? I'm going to write a 2x right here, and a 2x right here, and a 2x right here. I just want it by every single term. You okay with that? So here the x's simplify to 1, and we have 8. Here the 2x simplifies to the 2x, and I have equals 5 plus 6x. Everybody okay with that? Now if I subtract 5 from both sides, I get 3 equals 6x. How do I solve that equation? Divide by 6. 1/2 equals x. How could I be sure that was correct? I could plug it in. 4 over 1/2 equals 5 over 2 times 1/2 plus 3. Well, 4 over 1/2, 4 over 1/2 is just 8, right? If I get rid of the fraction by multiplying by its reciprocal, that's a 1 and that's an 8. Remember that? 2 times 1/2 is just 1, so that's just 5, and that's just 3. Is 8 equal 5 plus 3? Yeah, so that's right. There's my answer. Okay? Now, some of the ones that you're going to have to do are a little bit more difficult because they look more like this. 4 over x plus 5 plus 2 over x minus 5 equals 32 over x squared minus 25. Do you remember doing these in Algebra 2? We spent like 3 weeks on them. Okay? If you remember, that's great. If you don't, I still remember, so I will tell you. Okay? We want to get rid of the denominator. Anytime we can get rid of the denominator, that makes it easier on us. Okay? So I'm going to get rid of the denominator. The way I'm going to get rid of the denominator is by looking at what denominators I have now. I have an x plus 5 and x minus 5, and then this. Is this something you know how to factor? It is, right? It's called the difference of squares. Do you remember talking about that? How do I factor the difference of squares? So x plus 5 and x minus 5. Okay? So now that new denominator is x plus 5, x minus 5. Well, I see a whole lot of x plus 5s and x minus 5s. That's helpful. Okay? In order to figure out what I need to multiply by, I need to be able to simplify everything. So anything that's part of the denominator, that's part of a current denominator right now, is what I want to multiply everything by to get rid of the denominator. Okay? So can I choose x plus 5 to multiply by everything by? Well, is it going to cancel that? It'll cancel this one, but not this one, right? So what if I also have an x minus 5? Well, that'll cancel. That'll cancel. And then those will both cancel. So is that good? So then I want to multiply everything by x plus 5, x minus 5. Now, it's not necessary to write it by every single term, but I like to do that because I like to do stuff like this. That cancels with that. And I'm left for that term, left with x, or 4 times x minus 5. For here, I like to be able to do that because that leaves me with 2 times x plus 5. And here, this is really nice because that goes away and so does that, and all I'm left with is 32. And that suddenly becomes just a linear equation that we can solve. Distribute 4x minus 20. Distribute 2x plus 10 equals 32. Combining my like terms, I have 4x and 2x. Negative 20 and positive 10. All I have left to do is add 10 to both sides and divide by 6. Now, the only really negative part about me crossing everything out like this, like I like to do, is it's kind of hard to plug stuff back in so you can see it all. Now, I don't like eliminate it with a black Sharpie, right? So I can still see what it says. It just makes it a little bit more difficult. I have to be careful with my signs, right? So 4 over 12 plus 2 over 2 equals 32 over 49 minus 25. What's 49 minus 25? 24? So what is 4 over 12? 1/3. It's 2 over 2. What's 32 over 24? They're both divisible by what? 8, right? 2, yes, for sure, but then 2 more and then 2 more, right? So they're both divisible by 8. So 8 over 3. Is that what I want to say? No, that's not what I want to say. 4 over 3. Sorry about that. You guys are like, you are not, that is not right. Sorry. What's 1/3 plus 1? 4/3, right? So does 4/3 equal 4/3? Yeah. So this is right. Now, something that you haven't seen before, because it's not something we really dealt with in Algebra 2, is for all of these questions, okay, all these examples I've shown you so far, when it asks you in your homework, it doesn't say solve it. It says find the solution set, which is saying solve it, right? It's just a different way to say it. Yeah. So if I say what is the solution set for this, it would say the solution set is 1/2. And we're talking about sets of numbers. Remember when we talked about these braces for writing a set of numbers? It just has those braces there. The solution set for this would be 7. Instead of x equals 7, it just wants a 7. Does that make sense? Okay, just a different way to write the answer. You understand how to do all this other stuff, and so writing the answer is not going to be a big deal for that. Okay, so on some of these you're going to have to just take the denominators that are there. Sometimes you might have to factor and figure out a denominator that way. Any questions so far? Okay. Ask questions later on if you need. You know, you can always come back here and we can talk. Or I can come to your desk, either one. Okay. Number 4, so we've already done 1, 2, 3, and 5, right? We can solve a linear equation in one variable. We can solve linear equations containing fractions. And now we remember how to solve rational equations with variables in the denominator. And we already talked about the fact that this is the word problems. Okay. Recognizing identities, conditional equations, and inconsistent equations. We talked about this in Algebra 2, but definitely not with these words. Okay, so let me make sure you understand what they all mean. Okay, first of all, an identity. An identity is true for everything. For example, x plus 3 equals x plus 2 plus 1. What value for x can I put in here that will make this statement true? I could put 0. I could put 5. Wouldn't 5 work? What about 12? 364? -7? Anything that I put in here will work, because if I simplify the right-hand side of this equation, I get x plus 3. Does x plus 3 equal x plus 3? Yes. So no matter what value of x I put in here, it will work. It works every time. Okay? A conditional statement or a conditional equation is true for at least one thing, at least one x value. For example, 2x plus 3 equals 17. Well, if I subtract 3 from both sides, I get 2x equals 14. And I divide both sides by 2, I get x equals 7. This equation right here is a conditional equation because it only works for x equals 7. Now, some of the rational functions, some of the quadratic functions, especially cubic functions, polynomial functions, all sorts of stuff like that, they can have multiple answers. You remember that? Okay? Those are still conditional statements because they're true for at least one value. But not every single value like an identity would be. Do you see the difference? Okay. And the last thing you have to know is an inconsistent equation. Inconsistent. An inconsistent equation would be like this. X equals x plus 7. What value of x also equals that same value of x when you add 7 to it? Nothing, right? There's no value of x that we can choose that x will equal x plus 7. Okay? And in fact, if I try to solve this, I get 0 equals 7. Will 0 equal 7? Ever? I think it's rain. Yeah. Okay. So, Could you tell the difference between an identity, a conditional statement, or an inconsistent statement? Statement, equation, that kind of thing. Okay? So those are our 5 objectives for the day. Now, I know I only did 2 or 3, especially with these rational functions, but that's something we can definitely sit and work on later on if you need to. I know some of you are pretty comfortable with them, and so you don't need a whole bunch of examples, but I will be here to help you if you need my help. Okay? Any questions? Peace.